Hello, everyone, and welcome to this Devtoberfest session looking at the SAP Cloud Application Programming Model, and more specifically, its new database architecture that was introduced in the recent 7.0 version of the Cloud Application Programming Model. We're going to have a look at how this changes the ability to support multiple different types of databases with a CAP application, how it allows us to adapt our models for specific differences in different databases that we might want to run our application on. But we're also going to look at how we do hybrid testing, which means doing our development locally, either in Visual Studio Code on our local laptops or in the Business Application Studio in the cloud, but still connect remotely to a database service or even a database running locally. I'm going to do three things in today's session. I'm going to take a single project, and I'm going to connect it to SQLite, but I'm also going to connect it to PostgreSQL, and I'm going to connect it to HANA Cloud. I'm going to run all this from my local laptop using Visual Studio Code. My SQLite will be a disk persistence on my local laptop. The Postgres database will be running in a Docker image on my local laptop as well, but it could just as easily be running in the managed Postgres service on BTP. But I'm also going to connect to SAP HANA Cloud running on BTP, but I'm going to do that remotely from my local laptop. So I'll be doing all my coding and testing locally and connecting remotely. And we'll see how we can put all these three things together, all these different approaches together in a single application, a single project, how we can test them all in parallel, and even some cool little utilities that can help you with that. So let's go ahead and look here. If I come to the cookbook section of the Cloud Application Programming Model help documentation, we see a databases section. And now we see multiple database types. We've always had SAP HANA Cloud, of course, is our main productive database target with the Cloud Application Programming Model. And generally, SQLite has been there just for local testing, while you're doing development locally. But what we see with the 7.0 version is a new introduction of an architecture to more easily plug in additional database types and libraries to support those, and the introduction of community-supported plugins for the Cloud Application Programming Model as well. And that's exactly what we have here with the SQLite or the Postgres versions. Is an npm package that's not in the @SAP namespace like the @SAP CDS, but in this @cap-js. And if we have a look at this package over here in npm, you're going to see, not only is the namespace different, but one of the very important differences is I can go to a public GitHub repository and I can see all the source code for this this particular module. And in fact, this is a model repo for all the SQL-based database services, so you'll find the Postgres and the SQLite implementations both in this one GitHub repository. It's also running under an Apache 2.0 license, as opposed to the core CAP framework, which is still under the SAP developer license. This allows community contributions, of which we've already seen community members, non-SAP employees, contributing to this project to help maintain it and enhance it. So I think this is a really important step for the Cloud Application Programming Model, and kind of brought these other database implementations not into a fully supported status by SAP, but to the point where you could use them and get community support for them, and SAP will support the plugin framework that they go into, and then the community can provide the specific implementation for other databases that SAP might not be able to provide. And that's exactly what we're seeing here. And it's very easy to add these to your project now. You simply add the module, like cap.js, cap-as Postgres. And they also use the new plugin, the CDS plugin approach, so that they can auto-configure themselves. So we're not having to mess with a lot of detailed configuration, how to set this up. I'll show you all this in a project in just a minute, but it's really simple to get started using these other database approaches. And in fact, the HANA is very similar now as well. And we still can go into the package JSON file and use a configuration section, a CDS configuration section of the package JSON if we want to do some configuration of a particular target database. And that's really neat because we can just configure the parts that we absolutely need to override something, to provide different settings. And they even have a getting started guide here. Like I said, I'm going to use Postgres running in a Docker container on my local machine. It's very easy to set up. They have some simple instructions. That's exactly what I did in my project, which we'll look at here in a minute. Or you can bind to it on BTP, which we'll talk more about in a minute, because that's exactly what we're going to do with the HANA service as well. There's some cool functionality there that's not brand new in 7.0, but I think not too many people know about it, about using binding, CDS bind, to connect in a very secure manner for this localized testing. So the project that we're going to have a look at today is one that is out here on GitHub.com in the SAP samples repository, or I should say the SAP samples organization. And the repo is named cloud-cap-HANA-SW API. Now, this is a project that I maintain. I created this a couple years ago as a fun example. It uses Star Wars, planets and spaceships and all kinds of stuff from the Star Wars universe. There was actually an existing project that was originally developed in Python as a learning example, and fairly famous because it's been ported to a lot of different environments and different programming languages. And I decided, I'll take this existing project, swapi.dev, and convert it over into the cloud application programming model. And it's a fairly robust data model. That's one of the things I like about it. It's not simplistic. It's got a lot of many-to-many relationships in it. So it's allowed me over the years to demonstrate a lot of different modeling techniques using the cloud application programming model. So you can take a look at everything that I'm going to show you here in this project. It's all available on GitHub. Now, what I've done recently with this project is I've expanded it to include configuration and setup to run the application from SQLite, Postgres, or HANA Cloud. But maybe before I do that, I'll just do a CDS run here and just quickly show you a little bit about the application. I don't want to go into a ton of detail, but I'll just give you an idea of what we're running here. Like I said, there's entities for the different films in Star Wars, the different people that you encounter, the different planets, the different starships, vehicles, all this kind of metadata about the movies. For instance, if I go into and I didn't run that very well, did I? There we are. I think I've recovered from my my mistake there. I was running it with the wrong command. And once again, we'll come back to that in a minute, why that didn't work and why it is going to work this time in just a minute. But first, back to the little demo. There we are. Now my data is actually loading from the backend database, and there's my people entity. And for instance, this project has lots of different things that I'm trying to demonstrate. For instance, you can access the OData v2 version. A plain REST version of the entities as well. What else do we have built in here? The Swagger UI. to test the entities as well. That's all built in. GraphQL support. Which didn't work. There it is. Oh, there we are. GraphQL support. So, try to create a fairly large, fairly robust, realistic kind of application, which made it a good case to showcase the new database model approaches there. So sorry about a few hiccups there, but hey, that's what happens when you start messing around live here. So what we see if we come to the package JSON in the root of the project, that's where we do most of our configuration that impacts the cloud application programming model. And a lot of it now is just whatever you list in the dependencies is going to control what's available. So for instance, if we want Postgres support, the main thing that we have to do is add the cap-js Postgres module to our project. And if you are just running with the default configuration, that's all you really need to do in order to add that to your project. And the same thing here with the SQLite, if I want a SQLite support. And we've got a similar HANA one, but it's in the SAP namespace. So unlike the Postgres and the SQLite, it's not released as an open source community project. It's maintained under the SAP developer license by SAP. So it falls into a different namespace. But it works the same way with the plugin technology, with the auto configuration. Just adding that module will do most of what you need to link it into your project. And we no longer have to add the HANA client as a direct dependency. When you add the Add SAP CDS HANA module, it will inherit and load the HANA client behind the scenes for you. Now, while we're in here, you can do some configuration. And we still have the CDS requires. And I've got a lot of different configurations, so I can demo many different capabilities of CDS. But in the CDS requires section, you can do configuration for the different database. And what I've done is I've set up different profiles. So I have a SQLite profile. I have a Postgres profile that I've just called PG. And then I've got basically the default profile, which will be my HANA Cloud one. So like the fallback if a more specific profile isn't suggested. So HANA Cloud is my default, and then SQLite and Postgres are my other two options that I can run my application with simply by, when I start it up, telling it what profile I want to run it under. Now I've got some configuration here, and I wouldn't necessarily need to tell the kind and the implementation. That should be inherited automatically by the plugin architecture. But I wanted to add it to showcase some of the to help point it out here in this example. But what I am doing is I'm overriding SQLite instead of using an in-memory version. It's going to write its persistence to a file, so my data is persisted between tests. We'll come back to this part in a second. The Postgres, because I'm running in a Docker container, I do need to give it some credentials. So I'm just telling it, connect to localhost, and this is the port that it's running on, user, password, just the defaults. If I look at my Postgres, let me just bring it over here from another window. So I have it here running in Docker Desktop. Here's my Postgres database running locally. And to install this, I've got the scripts that are basically right from I put them here in a DB Postgres folder, is you need to create a little configuration file that says that you want to load Postgres. You can set the initial password. You can set the port that you want it to run on. And I set mine to always restart when Docker restarts. And then you can call the shell script, basically a Docker compose, to load the configuration from this configuration file. And that's it. That's all I did to install Postgres and make it available to run my CAP applications on locally. So now what we can see here is if I want to start running under these different, all I have to do is say CDS watch and then add -- profile, and give it a profile name, and that's what it's going to run under. So I can say, for instance, profile SQLite. And now this will start my CAP application, but it's going to connect to a SQLite database instead of a remote HANA database. And you can see that right here, connect to DB SQLite URL DB SQLite. And once it finished, there, it started up. I can come here and I can run the application, and the same sort of thing will be available. There's my people. But this time, the running application, the CAP application, is still running on my local machine, but now it's connecting not to a remote HANA database, but to a little local SQLite database. And I can very quickly switch to a different persistence here. If I just restart my CDS watch, I can say profile PG for Postgres, and now we'll see it restart the CAP server. And right here, connect using bindings. Well, that scrolled by fast, but let me pull. Connect using bindings from CDS services JSON, connect to database Postgres, and you see my configuration options that I supplied in my profile. Now, I could have even created multiple Postgres profiles in this package JSON file, say for local Postgres testing with SQLite, with Docker, or I could have set up a whole nother profile that connected to a Postgres instance running in the cloud, say on BTP in the managed service. I can maintain these different profiles and quickly switch my testing without having to redeploy anything, or reconnect. And right here, let me get back. Now, if I run my application, it's going to look the same as you test it. It's hard to tell the difference because all these databases should work the same once they're, that's the point of what we're doing with the cloud application programming model is abstracting them. So the data model and everything works the same, but I have the ability to easily switch for different test scenarios. And just to kind of complete the cycle, we started with HANA, but I'm gonna do this again. I'm gonna say CDS watch profile hybrid for hybrid testing, and then it's going to go to the default profile, which is my HANA, and you're going to see, and I'll let it finish starting up here because otherwise it just scroll past what we want to see, is that it's connected to my HANA database, and you see the remote database URL and the schema and the user that's connected with. Of course, it doesn't show you the password, but it's loading a password and a certificate to connect to that remote HANA database. So now when we test, now when we're running the same service, but now the data is coming from a remote HANA cloud database running on BTP. So super easy to set up different database scenarios, very easy to test, and switcher testing between different database scenarios as well. All right, let's talk a little bit more about the actual database modeling. And I'm going to go ahead and stop my service here. I've got some scripts here just to make these commands a little easier to remember. They're all basically CDS watch and passing in the hybrid, but I've set up different little scripts to do SQLite directly. So I could just also come here and say npm run SQLite, and it's just going to be a shortcut to run that same command, CDS watch profile SQLite. But this profile command isn't just for testing your application. It can also be used on deployment. So if I've got a data model and I need to deploy it into another database, you might be used to with HANA doing a CDS deploy to HANA and giving it your HDI container name, and it will run the HDI deploy for you. But we can do the same sort of commands to also deploy into a persistent SQLite, because I'm not using the in-memory SQLite, so my data persists, my data model and my data persist in a file in between runs of my application. So I need to deploy the data structures, data model to it. So I just have a CDS deploy command, the same command that you might be used to using to deploy to the HANA database, but you just use that same profile. You tell it profile SQLite, and then it's going to deploy to the SQLite database. The same thing with Postgres. Use a CDS deploy, profile Postgres, or PG in this case, and it's going to deploy to the Postgres database. We even have the ability to configure schema evolution. I have it set to auto, so you get the same sort of capabilities of adjusting the database artifacts automatically, very similar to the way that HDI does, but for these other database targets as well. So once again, trying to make it super simple to switch between and test on multiple database targets at the same time from the same project. So far, I've not changed anything about my project content in order to target different databases. All I've messed around with is this package JSON and just having parallel profiles and then a couple easy scripts to switch between them. But what happens if you do need something that is database specific? You need to use a feature that is maybe only supported by the HANA database. And you don't want to set up separate projects or complicated scripts in order to change your database artifacts depending upon the target. This is where we have a really easy feature in CAP where we can do extensions to a base model based upon whatever target that database type that we're looking at. And that's exactly what I've set up here with the in the SQLite profile. You see this DB-EXT. So this allows us to override the database model. And basically what I'm telling it here, instead of using the normal DB folder and the files that you find there, the schema.cds, in my case, I've got one root database model file. I say, instead of loading that, load from DB and then a folder called SQLite. And I've just got an index CDS there. Now for Postgres, I didn't need any differences, so I just told it to also load from DB SQLite. Now don't be confused by the name. That was just because I set this up with SQLite first, and then I was lazy. I didn't feel like renaming it when I extended it to also be Postgres. But basically SQLite and Postgres, in my case, are going to share the same data model. And then for HANA, I tell it to load a different data model. I tell it to load model DB HANA. Now, yes, I now have two different entry points. I've got an index CDS in the HANA folder, and I've got an index CDS in the SQLite folder. But I haven't duplicated my data model. All of my data model is still here in the schema CDS file in the root of DB. And you see here, it's a pretty large data model. I've got a lot of stuff in here. I've got some annotations that I want inherited, but it's a fairly large, complex data model. If I look at the SQLite index CDS, all I'm doing is saying using my namespace, Star Wars, from backing up a directory and schema CDS. So basically, it's going to load this, if it's deploying to SQLite, or it's deploying to Postgres, it's going to load index CDS in the SQLite directory, which is really just going to defer back to my schema.cds in my root. So I'm making no database-specific enhancements here. I just want the base data model. Now let's look at the HANA version. So this index CDS that's in the HANA folder, well, I load the same thing. I tell it to load the base model. So I'm not having to duplicate any of my data modeling. Everything is still there from the base model. But I'm going to do two things. I'm going to extend one of the existing data models with some HANA specific features, and then I'm going to create a view that will specifically only be deployed if I'm targeting HANA. That I'm going to use some features that wouldn't be possible on SQLite or Postgres, or aren't supported yet at least, and then create a view that will only exist on the HANA database. So we have the ability to add features by not having to recreate the whole entity. I'm able to extend the existing entity. So I'm extending the people entity, and I'm taking one of the columns, I'm saying extend name, that attribute, the name column in this particular table, with, and then we have an annotation, SQL append, which means whatever SQL syntax that the compiler will create in order to generate this entity and this attribute which will turn into a table and a column in the database, but then append some SQL to it. And this SQL, CAP doesn't care about. I mean, it doesn't try to parse it. It doesn't try to figure it out. Whatever you put in here, it's going to put on the end of the create, update SQL statements that it uses to generate this entity or update this entity. So I'm telling it fuzzy search index on, because fuzzy search indexes are something that's supported on HANA. So I can get a full text search index generated on this column, but only when I'm deploying to the HANA database. Otherwise, I'll have the same entity with the same column on Postgres and SQLite, but it just won't have the additional search index built on it. Now, we can also add entirely new entities and views in this method as well. That's what I'm doing here. I'm defining a new view, tallest person, that will only exist when this is deployed to the HANA database. And it's just a view on top of the people entity, but I'm doing a select distinct, first value of a name, order by height, descending. So I'm going to get the tallest person by creating a view here. Now this uses some syntax that, as I said, is only supported currently when you're targeting the HANA database. Therefore, I don't want to get a deployment error when I deploy to SQLite or Postgres. No problem, because I've separated it out in this way. So, I have the ability to come here. Let's just do, make sure I'm up to date. I can do it. So we've seen how we can separate our data model and how we're able to then deploy slightly different versions without maintaining copies of our data model, but we can target the databases. But I want to take you to another topic here, which is actually how we were doing that testing. Because remember here, if I go back and I do the CDS watch profile hybrid, let's just start this up again. You see this bound DB to Cloud Foundry. Once again, to Cloud Foundry managed service Star Wars key. And then we see it gets connected to the database, connected database HANA. It's got all the database credentials to connect to the database. So from my local BC, I'm connecting remotely. Now it's using the bindings from a file, this .cds services JSON. Now the cool thing about this, unlike past approaches to local testing or hybrid testing where we have our CAP application running, we've had to use a .env file or a default -env JSON file. And we actually had to store the credentials, the username, password, certificate, and all of that in that file. And if you weren't careful, it was really easy to push that file maybe to a public Git repository and then expose your passwords. It's not great to store passwords in a clear text file. So CDS has come up, or the Cloud Application Programming Model has come up with a really cool technique to handle this. So what you're able to do is you're able to issue a command, CDS bind, and then you tell it the service that you want to bind to. Star Wars is the name of my Cloud Foundry HDI service. In fact, let me just do a CF services here and pull the list of all my services. And here you see I have a service named Star Wars. Is a HANA HDI shared. So this is my HDI container on Cloud Foundry that is connected to my HANA database, and that's how I'm deploying and testing here. If I want my CAP application locally to use that during testing, all I have to do is say CDS bind and --2, and then the name of the service, Star Wars. And when I do that, it's reading my Cloud Foundry configuration. So it's connecting to Cloud Foundry, and it says, okay, so I found the key and the information about how to connect to that service, and I've written it into this file, the CDS private JSON. Now, if I go look at the CDS private JSON, this is the best part. It's got the endpoint and the org and space, but it doesn't have any credentials. It doesn't store any of the sensitive information. What it does is every time it needs that information, it's going to call back to Cloud Foundry and retrieve it at that time. So as I do the, if I come back here, as I do the CDS watch, and I tell it profile hybrid so it knows to load HANA, and once again, we'll give it just a second to start up, otherwise it's going to be scrolling right past us. What we see on startup, there we are, is that it is using the bindings from this configuration, but right here at this time, when it connects to the HANA database, it first had to call to Cloud Foundry, look up these credentials, like the host, the port, the username, the password, the certificate. None of that is stored in this file. It's retrieved each time that we need to make a request to start up our service. And then it connects securely to the remote HANA database without ever storing those credentials. And that's a really nice way to do this local hybrid testing. I don't have to deploy my whole application to the BTP runtime in order to test with a real HANA database. I can make quick changes locally, either in the Business Application Studio or VS Code, and immediately test them against the HANA database. So that's a really great feature. And the same thing is happening behind the scenes when we connect to Postgres or SQLite. It just so happens that if I were, when I do the CDS watch with the other profiles, it doesn't need the binding because I'm not connected to a remote service. But like I said earlier, the same thing that I'm doing with the HANA Cloud instance, I could use the Postgres managed service on Cloud Foundry as well, or on BTP, I should say. And bind to it, and then connect remotely to it, exactly like the HANA is being used here. So we have that ability to use this for the CDS bind and hybrid testing for different services. And this isn't limited to just databases either. This is a feature of the Cloud Application Programming Model that you can use to bind to a UAA, to a destination, all kinds of different services that you might want to utilize in your CAP application so that you can test locally without having to deploy your application until you're ready to do so. And it's a great time saver when you're doing development. And the last thing I want to tell you about is a little tool called the HANA CLI. It's a little development helper that we built and share on GitHub that you can install via npm install HANA CLI. And it can be helpful for introspecting your database while you are doing development. And I want to show you how this works and reuses the CAP hybrid testing that I just talked to you about, and also just a brand new feature that's been added to a couple commands that you can use it against SQLite and Postgres as well when in the context of a CAP application. So first of all, what I have here is I can do HANA CLI, and for instance, I can do system info, and it's going to tell me a little bit about the HANA database. But what we see here, and it takes a second on the first startup, there we are. What you see here is it's using connection configuration loaded via the same CDS RC private JSON. So it's doing the exact same thing that our CDS watch did when we started up. When you use this tool in the same folder as a CAP project, it can reuse the Cloud Application Programming Model libraries and the configuration that's part of your project, that CDS bind, and do the exact same thing that CDS is doing. It will look up your credentials dynamically at each command and connect to the database remotely. So this is showing us, the user and a little bit about the HANA Cloud database instance that we're connected to, by just sending queries to that database using, piping them through this CDS bind. So pretty cool feature. Now, the HANA CLI still supports non-CAP projects as well. You have to maintain the older configuration file format, the default env JSON or the .env file. So if you aren't doing CAP development, if you're doing direct SQL development, it still supports that. That was what it was originally built for, but it's been adapted to also utilize the CDS bind functionality. So we can do things like I can come here and I can say HANA CLI tables. And what it's going to do is it's going to list all database tables in whatever schema or HDI container that I'm currently connected to. And because I'm in the same folder as this project, it knows what project this, or what HDI container this project is connected to. So it's automatically showed me all the tables that are part of this project that are deployed by that particular data model that I showed you. For instance, here's our Star Wars people table that we looked at. And I can do things like HANA CLI inspect table and look at the people table. And we'll see information about the table. Okay. There we are, including, I think, that's our, well, I'll show you another view of it. So, yeah, let me go ahead and say output SQL. There we are. This not only shows us, the table structure, but we can see the SQL that was generated by the Cloud Application Programming Model in order to build this table in the database. And for instance, I can see my fuzzy search index is turned on for the name column. So I'm seeing the results of that extended modeling when I deploy it to the HANA database. But so this tool can also be used against these profiles. So if I come here and I say table and I say profile-p, that's the shortcut for profile, and I say SQLite, then it's going to connect to the SQLite database that's running locally and give me the tables that it finds there. And notice they're maybe a little bit different. For instance, here, all the HANA table names are all uppercase, right? Whereas in SQLite, they're mixed case, they're camel case. So we're seeing some differences in the underlying database that CDS is abstracting from us. So we know we're targeting a different database, the SQLite database. And I can do the same thing here if I change the profile, -p to PG, to use my Postgres profile. Now the command is connecting to the Postgres database. And again, little differences in the formatting or the output of the table names. But now I'm looking at the Postgres database. So sometimes, as you're doing deployment, you want to look at, well, what does that look like inside the database? Or maybe you haven't built a UI yet, and you want to have a look at the data in the database. We can do that as well. We can say query simple. That's a different query I got there. Query simple. Yeah, let's. From, oops. Star Wars people, and that'll run against, oh, I misspelled people, so that's going to error out, isn't it? Go ahead and let that go. Yeah, and of course it tells me that's an invalid table name. And that's connected to the HANA database, and it's read the data back from HANA for the people table. But let's run that same command, but now give it a profile Postgres. And now it's instead reading the data from the Postgres database. Should look largely the same. There might be some differences in the date format. Yeah, there are differences in the date format, for instance, but otherwise the same data, because I loaded the same source data into both targets. But this can help you as you're doing development, as you're doing troubleshooting, particularly if you are testing against multiple databases in parallel. See, it's very easy to run these introspection commands now that the HANA CLI supports the same profile capabilities. And I didn't have to set up different files or other sets of credentials. It's all reusing whatever configuration here is in the package JSON of the project. And enable to connect and utilize that to look at the whatever databases that you have configured as part of your project. So with that, we've come to the end of our time looking at this topic. I hope that I've introduced you to the new database architecture of the cloud application programming model. You can really see the power of how we're expanding the ability to work with multiple database targets, how you can model specific features for a particular database target without having to duplicate anything in your model, how you can easily test in parallel with different database targets, and some of the support capabilities that we have thanks to CDS bind and its very secure way to allow us to connect to remote resources. I hope you've enjoyed today's session, and look forward to seeing you in other Devtoberfest sessions as we go through the event.